Well, greetings, mathletes, and welcome back. Um, so, what we're going to be talking about today is data, and basically how to organize it, how to interpret different representations of data is actually where we're going with this. And so we're talking about pie charts and bar charts and things like that. And I don't know any better way to be able to interpret what they mean than to have to build one. So that's what we're going to do. We're actually going to start from scratch with some data, and then we're going to organize that data, and then we're going to go through and build our different types of charts from that data. So without any further ado, let's begin. And I have gone ahead and procured us some data here to play with. And let's just say, for the sake of this, and I totally made these numbers up, by the way, that these are test scores from some class, right? I believe there are 24, yeah, there's 24 data points altogether. And typically, when you're looking at data, um, the symbol that's used for, yikes, let's make that a little thinner. Um, there we go. For the size of your population, well, I'm not going to get too into the technicalities of it, but n is typically the number we use for the number of data points, right? So there's 24. So n is 24 in this case. Now, it's not in order. And typically, you don't get data in order. You get high values, low values, high values, low values, more low values, then high values. It just jumps all over the place. Um, and looking at this as future teachers, it would be nice to be able to organize these so you have a sense of how the class did. Looking at this right now, it's hard to tell if there's more A's than F's or if there's more C's than D's or things like that. You can go through and pick those things out if you start counting individually, but it'd be nice to have all of that stuff together in one place. And the easiest way to do that is to get these numbers in order. Now, I'm going to take this opportunity to talk about a stem and leaf plot because uh, it's not just, some of you are probably familiar with stem and leaf already, but it's not just a way of um, seeing how many things fall in a category, but it's really a nice way to get things organized and put numbers in order. And so we're going to do that. This is how it works. Okay, so you start with a stem, and I'm going to write that in. And then you have a leaf. And still, I haven't explained what those things are yet. Okay, so every number is broken down. This is usually done for two-digit numbers, sometimes three-digit numbers. We have a three-digit number in here, so we'll have to accommodate it. But we break each number into two parts. The ones place, for example, here the 6. This is your leaf. The other piece is your stem. Okay, and we're going to put these in order. So the first stem I see, and looking through this, I see, oh, it goes all the way down to 40s. Do we have anything in the 30s? So I'm just checking. I don't see anything in the 30s. A lot of the time, you know something about your data too and know what things are possible. But in this case, we don't. So the lowest value is in the 40s. So I know I have to start this at 4. And then I need to just account for everything else. I'm just going to put stuff up to here for right now. And then we'll continue. So this first number here, 56, 5 is the stem. So I have the stem right here, right? So here's my stem. And I just need to write in my leaf. So my leaf would be 6. I move to the next number here. The stem is 7 and the leaf is 8. So I'm going to move down to the 7s here. You know what? There we go. Put that 7 back in there. So 78. So we go 7, 8, and I'll cross that number off. It's good to cross them off as you go. Oh, the next one goes up to 9. So that means I need an 8 and a 9 in here. Okay. And so we're just going to start filling these things in. Let's see here. So 91. 81. And you notice I'm crossing them off as I use them so I don't lose my place. I know exactly where I am. I can go have lunch and come back and know exactly where I left off. Let's see, 72. So what we do when we start having repeat things is we stack them. So this is 72. So I have a new digit there. And then 61, 91, 99, 75, 54. I'm going to speed up on this here. 88, 7. Oops, I wrote that in the wrong place. Maybe I shouldn't speed up. 88, 76, 99. Ooh, 100. Okay, so that's a 3-digit number. We write in the first 2 digits in the stem, and it's 100, so that means it ends in a 0. All right, so now we've used that. Let's see, 66. Got that. 70. We'll write the 0 there. 78. 78. 51. 59. 83. 90. 70. And the last one is 41. Excuse me. Okay, so there's actually some things that we can tell right off the bat here, just looking at this. So one, I can tell that I have 8 things that fall in the 70s, right? I don't have to know exactly where they are, but if I do want to know exactly where they are, I know exactly what their values are. Right? This is 78, 72, 75, 76, 70, 78, 78, and 80. And 70. Ooh, can't do that. Right? So you can actually pick out their individual values still, which is quite nice. It makes it a nice compact way of storing the numbers. Now, the other thing about this is this lends itself to what's called a frequency distribution. Okay, so here's what we just basically did. A frequency distribution is broken up into a class and frequency. Okay, the classes could be anything. We could be talking about literal classes, freshman, sophomore, junior, senior, right? And I could be talking about how many students are in each category there. But most of the time when we're talking about classes, we're talking about a range of numbers. Okay, so here, if it starts with 40, that means that this class goes from 40 to 49. The 50s, this one goes from 50 to 59. 60s go from 60 to 69. And then we have 70 to 79. 80 to 89. 90 to 99, and then 100. 100 kind of sits out there all by itself, doesn't it? Even though, like if we were talking about grades, oh, that should be 109. They're supposed to be all the same width. If we're talking about grades, some of those aren't even possible, right? But now, the frequency we're talking about, whenever we're looking at a frequency, is basically how many times we get a data value that falls between these two numbers here. So how many data values do we have that fall between 40 and 49? Well, I have 41, right? That's the only one. So that means my frequency here is 1. Let me put it in red. Actually, maybe if I switch to pencil, there. I'm not sure that's better. There we go. Okay, now if we look at the 50s, anything that falls between 50 and 59 in this range, or in this data set, will count towards this frequency. So we had a frequency of 1 over here, and then for 50 through 59, we have 1, 2, 3, 4 data points here. So that has a frequency of 4. It's how frequent the data falls into that category, right? So from 60 to 69, we have 2. From 70 to 79, oh boy, we got 8 of those. From 80 to 89, we have 3. 90 to 99, we have 1, 2, 3, 4, 5. And then we have 100%, right? And so what this would be, this is a frequency distribution. This is it's a way of tallying up everything that we've just measured, right? So, yeah. Now, here's one of the things that's nice. Because of the way this thing is broken up, it's kind of a, what do you call it? A histogram or a bar chart. I always call this a poor man's histogram. And we haven't defined a histogram yet, but a histogram and a bar chart are very, very similar. If you take this and, you just look at the data values, and if I just put a box around the length of the data values, I have a little chart here for myself that shows what each category looks like. And if you crane your head over to the side here like this, right? Are you turning your head sideways? Yeah, it looks like a bar chart. You can see the bars here, right? You can even color them in if you want. Right? It looks more like a bar chart when you color in the numbers. Right? So you do have a visual display at the same time. And that's what we're going to be looking at, is how to put together other visual displays. This one's the nice one because you can look at this right now, this whole business right here, and you can see how the class is doing. If you're talking about interpreting test grades, I can see I had a whole bunch of these grades over here in the 90%, which is really good. I had 100%. That's always great. And then it was real heavy in the C's, only 2 D's, and then actually these last 2 would be combined because they're both F's, right? So you can see where there's gaps. I have gaps on the B's, I have gaps on the D's, and then I'm kind of heavy in the A's and the C's. So I find that, and actually it's kind of heavy in the F's also. So, things like that are always interesting. They give you insight into how your classes are doing. So, using these for your own grade book or being able to interpret what you're seeing if you have some kind of software that does this for you, it's good to know what you're looking at and how it was created in the first place. Okay, so let's go ahead and take a look at the next thing here. Let's see, how do I want to do this? Let's do it this way. I am going to get rid of the stem and leaf for the moment, and we're just going to look at that frequency table. I think I'm going to have to move my face too. Yeah, I think my face is going to have to go up here. There we go. Much better. Okay. I decided to take a moment to clean up the frequency distribution also, so that's what's different here. The what do you call it? This distribution here on the side is the same one we had in the middle before. I just moved it over. Okay. Now the other thing for the oops, I have it on eraser still. Let's try that again. Switch back there. Now, if you're going to build a histogram, okay, now a histogram is used when there aren't actually any gaps in the data. So for instance, like you can hit every score between 40 and 69, right? These gaps are kind of arbitrary. There's no what do you call it? Gap where there can't be any values, right? So this is what we would call continuous data. There's no jumps in the actual data, which means that the frequency table shouldn't have any jumps in it, and the classes all push right up against each other. And so a histogram is for not measuring, but for demonstrating, um, for being able to visualize what that looks like. So I'm going to put a little gap in here, but it looks like, let's see, I'm going to look through all my frequencies. It looks like the highest one is at 8. So I'm going to count by twos here. So 2, 4, 6, 8, 10. And we're going to build a little, excuse me, we're going to build a little histogram here. So in any case, let's see here, this would probably be easiest to divide up in tens down here. So let's do 10, 20, 30, 40, 50. Actually, let's start it. I'm going to start this at 40 just because. So it'll be 40, 50, 60, 70, 80, 90, 100, and 110. Right? So we got 40, 50, 60, 70, 80, 90, 100, and 110. Okay, now, so if we're going to do a histogram is kind of technically a type of bar chart. And so we have to make bars now. And the height of the bars are decided by the frequency. And actually, we need to mark this in. 2, 4, 6, 8, 10. There we go. Okay, so this first one goes from 40 to 49, right? And so I'm not going to go into all the technicalities of how to mark the x-axis. There's actually a lot of really weird little rules, but I'm just going to kind of sketch this in. The frequency is 1, which means we only go up to 1, which is a very small bar, right? So that's my first bar there. Then the second one goes from 50 to 59, so that's this next region here, and that goes up to 4. So that's at this height. This is actually a lot easier. I should have turned on the grid for this, but I think we get the idea. Okay, so there's my second bar. And then from 60 to 69 would be the next one here, and that has a height of 2, so that's back down here again. And then from 70 to 79, we go all the way up to 8, right? That's where most of the data is, or of all the little pieces here, that's the biggest one anyhow. And then from 80 to 89, we have 3. So that's going to be somewhere like in here, right? I'm trying to make the width correct. From 90 to 99, we have 5. That's actually not too bad, is it? And then 100 to 110, we have 1, right? One little guy here. Now, the big thing that's going to draw the distinction between a histogram and a bar chart is that you notice all the bars here, there's no gaps between them, right? These are all pushed right up against each other. There are no gaps. So anytime you're looking at something and it has no gaps, you can just say it's a histogram, right? That's technically a histogram is a type of bar chart, but we usually draw a distinction between the two of them. Now, the other thing, especially if you have such poor art skills as I do, it's going to be really hard to tell how actually high these things are. We can kind of see how big they are relative to each other. But, excuse me, one of the things that does often happen when it's hard to tell like this is you put the number of the frequency on top, just so you can tell. I know a lot of the time when you do this, like in Excel or things like that, that's one of the options to make it a bar or to make it a histogram that has the numbers on top of each bar. Okay, so that is our histogram. It's pretty straightforward. Now, let's go ahead and take a look at the next piece of this here. So let me select this. I'm going to erase that. Okay, now the next thing we're going to talk about is relative frequency. Oh, that didn't work at all, did it? Let's try that one more time. Okay, yeah. So I want relative frequency. Why is it doing that? Okay, let's try this one more time. Relative frequency. There we go. It worked. Okay. Um. Now the relative frequency is really looking at the percentage of the whole that that particular class is taking up. So here, we're going to need our the total number of entries here. So our total, let's see, 1, 5, 7, 15, 18. Why can't I do that? 23, 24. Okay, so there's 24 students in this particular class. Okay, if I want the relative frequency, what I start with is whatever fraction that whatever fraction that class has. So that's 1 out of 24, and then let's see, this is 4 out of 24, and this is 2 out of 24, and this is 8 out of 24, and this one is 3 out of 24, 5 out of 24, and 1 out of 24. Okay, so those are the relative frequencies. It's almost never given as a fraction, though. It's almost always given as a decimal or as a percentage. So we have to convert all of these. And yeah. So we'll just do that. So 1 divided by 24 is going to give us our first approximation. We're just going to round these to one decimal place at the moment. So this is 0.04 or 4%. Okay. And then let's see, 4 out of 24. We'll just do that one. Let's see here. 4 out of 24 is going to be 0.17. And I'm rounding these to two decimal places so that we can have so we can have a nice round number for the percentage. And then let's see here. 2 out of 24 is going to be 0.08 or 8%. 8 out of 24, well, that's actually 1/3. So I know that's going to be 0.33 if I round it to two decimal places, or 33%. So a good third of your class got C's. 3 out of 24. Let's see, that should be 1/8 or 0.125. Let's just double check. Yep, that comes out to 0.125 or 0.13 if we round it, so 13%. 5 out of 24 is 0.21 or 21%. And lastly, we have 1 out of 24, which we've already done, which is 0.04 or 4%. Okay, so all three of these represent different ways to write the relative frequency. That's basically what we're looking at here. So when you see relative frequency in a chart, though, you're not going to see all three of these. What you're going to see is one of these three, right? It's assumed that you can move around to the other ones if you need to. Now, here's the other thing, is that relative frequency, a lot of the time, you break it up using a pie chart. Now, this one's going to be actually fairly difficult to break up using a pie chart, just because of the fact that if we're going to measure the angles precisely, that's very difficult to do here digitally, at least with the tools I have at hand. So I'm going to go ahead and sketch this in, and we'll talk about what that actually means, and then we'll talk about how to find the angles. We're not going to be able to measure the angles correctly, but we will be able to find them. So, okay, so first off, we're going to make an attempt at making a circle here. Okay, so let's try this. Let's see what we can do. Okay, that was a pretty good circle. I'm going to take it. Got it on the first try. Okay, so basically, when we break these things up, right, 4% is a very small amount. And it would be a very, very narrow angle here. I'm just going to say that's 4%. right? And that is, you would have a label on there, 40 to 49. The next one's 17%, so that's a little bigger, right? And this one is 17%, 50 to 59. And then 8%, which is going to be smaller again. So you can see how this is breaking up here. So that's 8%, right? 60 through 69. And what you're doing is you're carving this whole thing up. The biggest piece is going to be your 33%, which is the next one, which should take up about a third of the circle. So I'm going to say it's about like that, which is 70 to 79. Right, and this would, a lot of the time these get color coded. There'll be a little legend in there telling you that each color represents a different thing measured. Now, if you're going to have to go through and find those angles in particular, what you end up doing to figure out the degree measure of those angles is you just multiply whatever the percentage is, the relative frequency, times, well, actually, it would be this one, multiply the decimal times 360. So like for the 4%, if I want to know what angle that is exactly, it's 0.04 times 360, right? And if I do that, 0.04 times 360, that means that that angle in there comes out to 14.4 degrees, right? And you could do that with all of them. It's the relative frequency times 360 degrees. And that tells you what angle, that tells you how to find the actual angle that you're dealing with. Right, so those things are kind of nice for that. So I'm not going to go through the whole thing here. We can see how to kind of piece this together. The percentage that you have for your relative percentage should be the percentage of the circle that's actually colored. So that way the area corresponds to the relative frequency. And it makes it easier for your eyes to look at and just see what areas are bigger than others, because human beings are made to look at pictures. They're not made to look at data, which is why we're translating all this data into more chunked down things. Okay, so let's see. And the last thing I want to look at, I'm going to actually cut some of this stuff off. I want to keep the frequency here. And yeah, that's mostly it. Just not the relative frequency. We are going to cut that off, and we're going to look at one last thing here. And that last thing we're going to look at is an actual bar chart. So looking at this, we have a bunch of information here. But this isn't typically the kind of information you would use to make a bar chart. You would have something a little bit different. So perhaps I wanted a grade distribution instead. So let's say here I want to break this up in terms of grades. Right? So we'll have a frequency distribution here. But I just want to do it with A, B, C, D, and F. Right? We're going to just break it up this way. Okay, so the number of A's, let's see here. So pretty much anything in these two categories is going to be the number of A's. So that means I have 6 A's altogether. The number of B's, well, that's just going to be this category here, right? Because it's 80 to 79. Those are your B's. So that's a 3. And then C's are going to be 70 to 79. There's 8 of those bad boys. And then D's, there's 2 of those. And for F's, we actually have to combine these last 2 categories. I have 5 F's. Okay, now I think this kind of illustrates the difference between a bar chart and a histogram. A histogram has data, right? It has numerical values that things fall between. But when I'm talking about A's, certainly there are numerical values, but those classes get fudged between teachers. Some teachers give an A all the way down to 85. So that doesn't have to be set in stone as far as that goes. These things are not quite as dependent on the actual raw scores. which means they are non-numerical categories, right? And when you have categories that aren't numbers, what you end up doing, you still give them a bar, and you still have this frequency height. 1, 2, 3, 4, 5, 6, 7, 8. This time I'm going to go all the way up to 8. But what you would do here is you would just draw an independent bar, and you would try to make it look better than mine, right? So you'd have a bar here by itself. And then for B, that only goes up to 3, so that would be here. And you notice this is already looking very different than the other one. For C's, let's see, there's 8 of those, so we're going to take that all the way to the top. You really should have them evenly spaced for aesthetic reasons, but we're going to forgive dear old Mr. Brian for this. Okay, and then D is at 2. And then F is at 5, which, yeah, should be about right there. Right, and so this is a bar chart, and you notice the big difference. A bar chart has gaps in it, right? That's the biggest difference between a bar chart and a histogram. If you're looking at it and it has gaps in it, it's a bar chart, right? If it doesn't have gaps, it's a histogram. Now that's different people categorize those differently, but for the most part, that's how you would tell, and that's how this book is doing it. All right, so that's the rundown on everything in this section, and so we'll go ahead and conclude things here. And so until next time, keep your pencils and your wits sharp.